And Ryan, we've got 12 people that I'm seeing in here. I'm going to go ahead and get started. So once again, good morning to everyone. Today, for the most part, we're going to be talking about pipes and what we can use them for. And of course, this will be, if you haven't already gotten to it or taken a look at it, an integral part of your repo that you are working on today. And this will appear, there's also going to be a portion of this, I talked to my small group about it, but there will be a portion of this that will be a short lecture type format. You need to pay attention to it and the least be aware of what is being covered so you can go look into it more later if you feel the need to. It will be on the sprint. You'll be responsible for it. So just be aware of that fact that when we talk about the different states that a process can be in, that will appear on your sprint tomorrow. So be sure to note that down. All right, so who can tell me maybe what a pipe is, what we use it for? Just a real quick and simple answer. One line. Pipe is a unidirectional channel between two processes that would otherwise be isolated from each other. Kai said to let different processes communicate with each other. Anybody else have anything? Stuff water moves through. Yeah, those are great answers. And what's one way that we were able to communicate when we forked between a child and a parent? We covered this yesterday, but it was unidirectional, I'll say that much. Something the child does. Yeah, when the child exits, it can communicate back with the parent. The problem is that the parent cannot communicate with the child. So pipes allow, basically you're putting in data in the right end of the pipe, and you can get data out of the read end of the pipe. And there's a real simple command for it that we're about to see. And kind of the magic behind it is if you fork after a pipe call, I'll just go ahead and say this, but you'll see it later on. One process can write to the pipe and the other can read from it. So you end up down the tree with what can be a really complex set of communication. Today, we will cover the basis of it in GP. You'll see more of it in your repo if you haven't gotten to that section yet. And of course, you'll be able to pose questions to Sean, who will be standing in for Beach today for the Q&A at regular time. He also will be covering the sprint challenge for us. So I'm going to make a new file here real quick. Just would help to make a new file. Okay, so today we are going to be all in the editor and not with Python Tutor. So, and just something I wanted to bring up. Does anybody know real quick? We kind of got into a discussion about it the other day, but these includes for the different commands that we're using, these new commands that we're happening to use. Does anybody know where you can access that information real quick? Let's say we're going to use the pipe command that we're introducing. Where can I find out all the information about this pipe command? Yep, the man, Justin. So, and you can actually also Google. You could just say pipe man in Google and it'll pull up the man page if you don't want to work out of the terminal. But yeah, if you just man pipe, and it's going to give you the information on what you need to include and more information than you possibly could want from it. So just remember that that's always available to you and all the information. And there, and like I said, you can Google it as well. So, and you can just hit Q to come out of the man. So just wanted to let y'all know, anybody that wasn't aware of that, that is available. And our standard input output. And we will say int main void. And we're just creating a buffer, giving it a size. Who can tell me there's a read, and in this buffer there's a read end and a write end. What part of the it's an integer. What part, which is the read, which is the write? Anybody know? The buffer is just a buff is for buffer. It's just a space we're creating to be able to make an input to for the sake of this program. There's nothing special about it. You're just making an array, and the FD is the pipe that we're creating. So what I was asking, does it, when you just call it this way, like we did on line 10, and you don't actually use array notation or point to where you want to access, it's going to start at the beginning index of it. So we created up on line 8, we created this array, and this will just access the array at the first index. The 0 will be in. This is pretty standard. The 1 is the out. We'll see another way of notating that later. And the 2, if you remember, is the standard error. We recall we messed with the little error output the other day, but more on that later. Does that answer your question, Kai? So this is just creating the pipe and populating FD. We could say FD at 0, read end at 1, right end. All right, I'm just going to continue on with it, and maybe it'll become a little bit more obvious as we run through the program what this is doing, okay? Now, we could fork right here, but because that is part of your independent project today, like I said, if you already haven't gotten to it, we're not going to do that. But if we wanted to do inter-process communication, we could fork right here. And be aware that's the terminology between two different processes. That's the official terminology between two different processes communicating with each other. It's quite complex and it goes on under the hood continuously. It involves very complex scheduling, which I believe we will cover later. I know part of that was taken out, but and then if we want to send data down the pipe, we can just call this bytes written equals write. You're talking about line 12, James? You're creating the pipe and populating it at the same time with that with the array from line 8. What I did screw up is that. Is that what you were seeing that you were asking about? This works just the way it's written. Is everything coming through? Just everything coming through fine now? Okay, I'll hash back over this real quick once we get done typing this out. There's not a whole lot to this. So remember, this is the right end of the pipe, so we're going to use the write command to write to this space of memory. We will write hello world, need our null terminator. $14. And then we can read data from the pipe. Remember, 0 was the read. Buffer. And we will just use size of buffer. We could put 1 right here where I'm writing the standard out file no. This is a little bit more of a semantic way of putting it, but we can look at that if you want to when we are done with this. Look back over this, see if I missed anything. Pipes.c. So should be able to run this now. We'll call this pipes pipes.c, Fluxtra pipes, pipes.c. I think this is right. We're getting a warning. That's fine. And I can say pipes. And we get the hello world. Kai, you were asking earlier, is this a little bit more apparent what's going on here now that we ran through it? Ah, now I see you're typing. Okay. What do you think would happen, let's say on line 14, if we change this number, and let's say we made it 10? Okay. The write command is you can think of a pipe as a virtual file, is how we were taught what a pipe was, and this is writing to that file, and it's just saying we have hello world. If you count this out, including the null terminator, we need 14 units to be able to store hello world. So we're giving it where we're saying to write, storing it in this variable bytes written, which is a type int. This is the beginning point where we start to write to. This is the string that we're writing into there. And this is the endpoint that we're writing to. Does that make sense? And then that kind of plays into my question that I'm asking. What would happen if I just changed that to a 10, do you think? Yes, correct. Correct, Stephen. So if I change this to a 10, and I compile it again, get that warning. And you can see down here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we didn't have a new line at the end because we didn't allocate enough, so it threw it right in front of my prompt. FD2 is up there, Kai, because I was going to write is writing hello world to an address that's an int, and that address is in the buffer that we created. And we're giving it where to write it in that buffer. And then the read statement is saying the same thing. Hold on a second so I can read everybody's questions. Okay. It's okay, Kai. I'm sorry if it wasn't really clear. But we're creating a pipe with a read end and a write end. That's what we've done right here. And we've created this array with a read end, a write end. The reason that we have the 2 there is the FD2 is we're creating the size of that array. Because we need a read end and a write end, like I put in the notes right here. and then we're declaring the pipe using that array, and we're writing into the pipe. Remember, this was the right end. This is what we're writing into it, and this is how much we're allocating to correctly write into it. We can write into a pipe as much as well until it reaches its limit as much as we want at a time. Then down here on the read, you are reading it from the read end. You're using size of buffer to give it, you could put an integer in here, and that's where we're using the buffer. See what you wrote, James? Char message 1 equals hello world. Int bytes written, right? FD1 message 1, string length of message 1. We can try that. So this is what you were wanting to do, James, to write it in? All right. Save it. 2 warnings received. It's wanting up here. I didn't even see your message until but now if I save that, run it again, we just have the other warning, and then I can run, and you get your hello world. But yeah, I suspected it was going to work, but I wasn't 100% sure that it was going to work. But yeah, I mean, there's a lot of different ways you can do this. The idea of this is just trying to show that you're writing into the pipe and from one end, and you're reading back out of the pipe from the other end. And like I said, you'll see a lot more of this in your work later today when you start to fork. And we're specifically not supposed to be forking in here because that's part of your assignment. You didn't get the exclamation mark though, James. It cut off your exclamation mark because of the string length. So you got your hello world. You could say, why don't we could say, would we put a +1 right here? No. Yeah, it's still not grabbing that last one. I'm unsure about this, to be honest. Uh, I was looking at the other one, James. There you get your hello world. But if we didn't put the +1, yeah, I just counted it back and I counted wrong in the beginning that we needed 14. And you're right, we actually needed 13. Yeah, I just counted it over again. That was. All right, well, I'm going to drop this code. If you're already not following along with it, you're free to mess with it on your own, but we need to move forward. But the idea of this was just to show, uh, without getting into too much detail, the pipe writing and then the pipe reading on the other end and outputting what it's reading. Comma misses from pages string. Nedham, where are you talking about a comma missing? Ah, and there you go, because this one was 14. James didn't put the comma in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. James, that should. Carla, to answer your question, we can go. Let's forget about everything James was asking about for a moment. For right here, this is just a more implicit way. You could also put, remember the output we talked about was 1. We can go in here. Just get a warning. And you get your hello world. Yes, the 14, you have to account for the null terminator like we talked about the other day. Carlo, to answer your question, remember I said that there's the standard out file no is the same as saying the standard is 0 is the read end, 1 is the write end, 2 is for error. When you create this array, people that have been with Beej notes in another lecture that people that have been working inside of Unix that have been working with C forever just intuitively know this. but it is easier. That's why we specifically mentioned it up here, but it's easier just to be real clear on what you're doing to use that alternative syntax with the standard out file no. And then you're just, for your writing, that's giving you where you're writing. You're writing into the buffer, and it's writing the bytes read, which was the integer that we got here. What do you, okay, so 14 counts for that, so string length plus 1, correct. The reason we got confused, James, is I thought I had miscounted, but you didn't put the comma in your, I just cut and pasted your code that you put, and you didn't put the comma in there, so we only needed 13. And we just put size of buffer. You could go in here, and if you put 10 right here, it's only going to read once again, we've truncated because we've only read that and we don't have the new line, the null terminator at the end. Yeah, I'm unsure about that string length, Kai and James. I don't specifically remembering ever doing it, and that wasn't part of anything that I looked over to be able to use that syntax. So, or we could put 14 right here, and you would get everything. But I meant put 14 right here. And you get your entire hello world. James, that's something to ask in Q&A. I don't know. You're getting beyond what we intended to cover in the GP, and that's great, but I don't want to say anything incorrect. So that's definitely something that either you can do more research on or present at Q&A. And just you were asking about this buffer that we put the number in. If you only made that buffer length 10, you see once again what happens, where we get the hello, we get 10 spaces. All right, so are there any more questions specifically about any of the syntax here? What's going on here? Addison, you're asking why write standard. I think Sean, looks like Sean put an answer there. And Sean put a very clear and concise answer to your question, Addison. Adam, let me look back. Thank you, Kai, for posting that. We solved the issue of the length. James talked about the standard file no, things that were missing. Addison, I missed this when you were mentioning earlier about writing to the zero and reading from one. In another lecture, when Beej goes into a lot of detail with this, he shows how you can even write. I think he did something where the two is generally the error, and he either read or wrote from the two, so you can interchange those around, but you're going against standard practice. And I'm not going to lie and tell you, I remember what he said was going on under the hood. That wasn't included in today's. That was something that he did a while back, but you can look more into that. But yeah, you are able to play with that a little bit, but there is standard convention that's generally followed that we talked about earlier: the zero, the read, the one, the write, the two, the error. Let's see what Brad's typing. And yeah, so the standard output, one, the write in. So Brad, what you just posted, you're saying the standard file number, the file number of standard input is zero. That's contradicting what is in here. That's going to be a question maybe Sean could jump in right now and answer. But as far as what Beej has in his original lecture and what's in the GP, this is what we were to present. I I don't know. I really don't know. Like I said, in one of his old lectures and in the GP that I've got, Beej covers it, and the example code I'm going off of, Beej covers it this way. So like I said, maybe Sean can chime in on that if he's in here, or that's a great question for Q&A. I have no idea. I do know you can interchange them. You can play around and get it to work a lot of different ways with the numbers, but I have no idea. So with that said, any more questions about the syntax here or what's going on? What Carlos typing? Yes, sir. That's identifying where we're writing. That first argument in the read and the write is identifying the position that we were talking about up here and from the array that we created. Makes sense? Okay. And then the next part that I'm going to talk about, I'll even, when I post this code later, I'll put a short little note in there about it. This is what I was saying is just going to be a quick talk that talks about the OS process states and scheduling that you probably will be responsible for on the sprint. And we'll see this when we do our next set of code when we're talking about one of these states. But the takeaway from it is that the operating system, remember we're working within the operating system, keeps track of the state of every process. And I can find the link to it, but there's actually a book that Beej talks about in another lecture called The Design of the Unix Operating System. That's a textbook that there are many different processes within or states that a process can be in, but the four ones that we will cover and how they interrelate, but the four ones we will cover are the basics that pretty much cover every scenario. So a process can go to sleep. Does anybody know when it might go to sleep? There's two different real instances where a process can go to sleep. And this gets kind of into the scheduling that the operating system is doing. Anybody have any idea when a process might go to sleep? The two instances where a process might go to sleep is if you know anything about scheduling, and there used to be a really good repo here that we did with a multi-level feedback queue that Sean, I remember doing it with Sean, and he had a link to an entire textbook that covered operating systems that had a whole chapter dedicated to it. But the scheduling is very complex, and many times per second, per millisecond, your computer is shifting back and forth, allocating time to certain processes, trying to maximize the use of memory and the efficiency of the processes that are running and the time that they're allocated to run in. So they can go to sleep if they use up their time slice. In other words, something else needs the CPU. And they can also go to sleep when they make a system call that blocks it. The two instances where that happens are when you try to read from an empty pipe or you try to write to a full pipe, if that makes sense. And we'll see more of this with the next set of code that we work on. But basically, it's just if they use up their time slice in the scheduling, or if they try to read from an empty pipe or write to a full pipe, and they wake up when the scheduler decides it's time to run again. In other words, when they've received a new time slice, they wake up. And also, if it's waiting to, you're trying to read from an empty pipe when something appears in that empty pipe and is written to that empty pipe for it to read, then it'll wake up. And vice versa, if you're trying to write to a full pipe when there's empty space, the process will wake up. To remove the compile warning, I think you can remove int bytes written equals and it should still work. Okay. And so we covered sleeping. There's running is another process, and that simply means the process is running on the CPU. There's ready to run, which means the process is awake and ready to be scheduled on a CPU as soon as one frees up. In other words, it's waiting for a slice of time from the CPU. It's ready to go. It's no longer has a need to sleep, but there's nowhere available for it to run. And the last one is when a process dies. When a process dies, anybody know what it becomes? The term, a single word for what it becomes. I think Beej joked about it being one of our favorite characters in classic horror movies. Starts with a Z. Yeah, zombies. It becomes a zombie. When a process dies, they become zombies until their parent process calls wait to reap the zombie process. And this is how the parent process can get the child's process exit status. And once again, we'll see more of this. We're about to do a set of code that involves zombies after we take a quick break. A question that also often comes up, since to reap that zombie of the child that's died, the parent has to be alive to be able to reap that. If the parent dies before the child and therefore it can't wait, we went over the wait the other day, the child is adopted by PID1, process ID1, which is also called the init process. And PID1 is like the great great grandfather of all processes, and it will wait for all of its children. So it will, if the parent dies, basically PID1 inherits all of the orphans, if you would. And like I said, we'll see some visual output on that when we do the code involving the zombies after the break. But I will put a short little notation in the code like I posted the other day of these terms in case there's more that you want to go over, in case there's more that you're not clear about. It's 3 past the hour right now, so we'll wait until about 8 past the hour to resume. Hey, Kai, what were you wanting explained again? For the zombie processes, I see Sean is typing, but we're about to run some code and then see actually all the different processes running in the terminal. So maybe it'll be a little bit more clear. Yeah, this may, like Nedim's saying, this may clear up some of it because we're going to see these actual processes running and we can talk more about each individual process as we do that. I've got a little bit of code to put in. So I just commented out the other code so that I can include it later on in the block that I. Sean, I'm going to read what Sean wrote real quick, but uh, good piece of information. Everybody be sure and read what Sean just posted in the board about the FD being an integer. James, what are you humming at? But Kai, this was just an example of how a pipe works. You'll, if you haven't gotten to it in the repo yet, you'll see a lot more. All right, so I think if you recall from yesterday, what's on line 32 here is the PID underscore T, the process ID type is a type that because this is strongly typed, we have to declare. And that's where we ran into the issue the other day with Python Tutor not recognizing that and us having to switch over to the editor. So if the process ID equals 0, what does that mean? Yep. Brad, it's a child process. So we can just say See, Nedham has a question there. If anybody wanted to answer that while I'm typing here. Otherwise, if it's not a child like we were doing the other day, we know it's the parent. All right, so I'm going to read another. I've got this in. John Kai, Nedham, YU, hit T. Looks like some people answered there. Okay, so Sean answered this question. So Addison's asking, what's the deal with the argument and exit? Yesterday was exit 1, now exit 3. What's the magic with these numbers? And off the top of my head, the exit code that were you talking, Addison, about the exit code we used when we had an error yesterday? And that PD error that we were using? Yeah. So exit 0 is a normal exit. a success, if you would. Exit 1 is an error. The exit 3, I believe, is an exception. I would have to Google it here. This is what's in the sample code, but an exit 3 is for an exception. Somebody. Kai, I saw that you. Yeah, one is a general, one is an error, 0 is success. The 3, I just Googled it. Exit code 3 can mean an uncaught exception since you don't seem to use except, and it's an uncaught exception. Generally means your system has run out of memory. I Yeah, Kai posted something with the exception codes. I'm going to go back to the code that we were working on here. Make sure I've got everything. I need to have a return. We'll go ahead and save this and run it. Compile. Where am I missing? Where am I missing? What am I missing? Oh, a colon instead of a semicolon. All right. So when we run this code that we had right here in this separate shell, I've got a few other things running here, but you see the child and the parent. When we ran this code, the child dies immediately and became a zombie. We don't have any code in here where it's prompting us to press return to wait. So what we're seeing right here is the parent, which is represented right here, has gone to sleep because it has nothing to do at this point, and the child has become a zombie. Is that clear to everybody? Ask any questions now about this. We can see our process ID here, the status, and the names over here that are letting us know what's going on. You can also see right here that the child's PPID is the same as the parent's ID. So when we go back over to here, and it's prompting us to press end return to wait, so the parent is going to wait, invoke the wait. Remember that the wait will reap the zombie. And now it's prompting us to return to exit. We'll go back over here and run the same command, the processes command, to see that and now we see that the only thing is that we once again have the parent, the zombie has been reaped, and the parent is now sleeping. So when we hit return to exit, what would we expect to have with the parent? When we exit and we run the command one more time, you see we no longer have any. The parent process is now gone as well. Does anybody have any questions? Certainly there's some questions involved with this. Kai's typing. And you know what, the process ID, I don't know if y'all remember I remember having to deal with it with Mongo, and when you had multiple shells running, you can manually kill these processes as well by hand, just with a kill command, where you put kill in the process ID after it, and it'll actually see what. Oh, y'all didn't do that in web. See, that's Sean said, bring the questions on. Over here. And then over in our separate bash, you've got the parent and the child. You can actually, let's see, child 14850. Kill 14850 should. Oh, it actually didn't kill it. Yeah, I think you can 1-4 if you kill the parent right here. And then run it again. Yeah, I don't know why that's not functioning. That's not in here. That was just something. I know you can kill the processes with that command, but it's not letting me do it. I'll post all this code, and like I said, I'll put the specifics that are in there that we just talked over real quick, so that you can look over them more or ask more questions about them. Definitely have your questions ready for the Q&A. And if anybody didn't have anything else, I will let y'all go at this point. I'll upload the video if anyone wants it, and I'll have the code if anybody wants to play around with it posted up fairly quickly after I type a few things into it. All right, well, I'm going to go ahead